Now, these replacement problems generally deal with the situation that arise when some components, whether it is men or machinery, require replacement because of reduced efficiency or breakdown or complete failure. Such decreased efficiency or complete failure may be either gradual or all of a sudden. So this is, if you go to any industry, there will be so many number of bulbs will be there to create lighting in the factory for the working of the particular persons on different machines. So when you install certain bulbs, they may fail after some time and you have to replace it. So there is intermittent replacement. So whenever there is a bulb failure, immediately it is a usual practice to replace it. So if you replace a failure and immediately on the next day, you may encounter 10 bulbs failures. So you will go and purchase 10 bulbs and replace it. After third day or something like that, you may encounter with 15 failures. So like that, the failures are going to increase after a certain time. So therefore, purchasing in single piece items and thereby getting them into factory and getting them the old failure bulbs replacing with the new ones is a laborious process. Therefore, we have to analyze the life of the bulbs and thereby you have to replace the entire lot at a particular point. Still, whether some bulbs are working, you have to replace them. So this is the replacement problem. So we are going to call it as a replacement policy in this particular chapter, and that is the main theme of the particular chapter. So it is either complete failure or sudden breakdown. Similarly, if you purchase a lathe machine, so lathe machine, it will continue to work if you work for it on for 8 hours a day. After some time, there may be vibrations after 5 to 6 years because of the repeated working of various parts of the machine. You may not get an accurate surface finish. You may encounter vibrations in the particular machine. Therefore, the surface quality of the component is going to decreasing. So in such a case, you have to replace the entire machine. So one has to analyze, repair or go for a purchase of a new. If repairs, if you go for a repair of the particular machine and you have to replace so many parts. If you go for repair like that, how much is the cost of replacement of certain parts? And if you go for a new machine, and what is the cost of the new machine? Like that, you have to balance the cost of the machines and their output, and thereby you have to go for a particular policy of replacement. So that is, a model is a replica of a real or existing system. A model is a replica of a real or existing system. It demonstrates the interrelationship between various decision variables in the system, providing a path to analyze the system behavior for improving its performance should be the primary objective of the model. So one has to improve the performance of the entire system. So if you take up the failure of the bulbs, and if we are unable to replace them, all the bulbs in a particular time, therefore there will not be any ventilation while working, and therefore the machines are to be stopped. So therefore the production is going to be reduced. So like this, all these are subsequent consequences of the impact of the failure of the particular bulbs. Similarly, if a particular machine completely goes to breakdown, therefore it is better to replace the parts immediately or better to replace the entire machine. So it is not a wise thing to go for the replacement of a particular machine or bulb after it fails. So you have to predict the failure time. You have to predict the failure time, and thereby you have to replace it. You have to get the bulbs, or you have to get the machine, replace it immediately. So like that, there will not be any effect on the product development or product on the production of the particular factory. So if you keep that particular machine, entire work will be go down automatically. Your production will be reduced. So that is a particular policy has to be devised, and thereby at a particular time, all those machines or bulbs are to be replaced. So this is uh, the mathematical model uses a set of equations establishing a relation between the decision variables to describe the system behavior. So for every replacement, there must be it is a wise thing to develop a mathematical model. According to the mathematical model, if you substitute the various decision variables, automatically you will arrive at a solution, and thereby implementing that particular solution will be taken up by various departments. So like that, the replacement goes on. The need for a decision of replacement is raised in any organization, both in case of men and machinery. In case of men and machinery also, from the theory of probability, it is possible to guess the chance of failure at various stages. So from the theory of probability, it is possible to guess. Suppose in a factory, I told you replacement of bulbs. So first of all, in the first week, there are 15 bulbs failure. In the next week, third 30 bulbs failure. And you have replaced immediately because they are less quantity. After some time, after a fifth day or seventh day or third week or something like the fourth week, there may be enormous number of failures. In such a case, it is very difficult to get all the bulbs and replace immediately. It will take a long time. So therefore, you have to guess if 15 bulbs failures are there in the fail in the first week, and the second week it is 30, and third week it is likely to be 50, or like that you have to guess, and thereby you have to uh, devise a policy to replace it. Objectives of replacement is very important. The objective of replacement is to direct the organization towards profit maximization or cost minimization. So if you are able to replace the entire system, replace the either machine or the bulbs at a particular point of time, automatically cost is also going to be minimized. At the same time, profit is also going to be minimized. Both are directly proportional. So, and in this particular case, if you go for mass purchase of bulbs, large quantity of purchase of bulbs, large quantity of machinery at a time, there will be huge discounts. Like that, you can save cost minimization. You can minimize the cost, and thereby uh, improve the efficiency of the system. So deciding the replacement policy that determines the optimal replacement age of equipment instead of using with the higher maintenance cost for a long time is the main objective of replacement problem. So deciding the replacement policy that determines the optimal replacement age of equipment. Optimal age of the equipment means so the life of the equipment has to be decided first. At 10 years it has replaced, 5 years it has to be replaced, or bulbs 1 year, the replacement time that you have to analyze. So that is the deciding the replacement quality that determines the optimal replacement age, optimal replacement time of equipment instead of using with higher maintenance cost for longer time. So there is no point when a particular machine fails and it is not advisable to replace all the parts with the higher maintenance costs. So if you replace it for some time with certain parts, certain parts are replaced and make the machine work, after some time, some other parts of the particular machine may fail. Again, if you go for maintenance, and they will cost in a different way. Like that, different costs are going to occurring on the particular machine. Therefore, the maintenance costs are becoming higher and therefore it is not advisable in such a situation. Better to go for replacement of the machine. So instead of go for higher maintenance cost, it is better to replace the particular machine. That is the always advisable. So one has to analyze the life of the machine. One has to analyze the life of the machine before still if it is working and you have to replace it. And if you are unable to replace it, if you continue to go on, it may suddenly fail at a particular point of time and it will incur much losses. So to stop to prevent the breakdown or to continue the production of the particular problem, continue the production of the particular factory, you have to see that the machine or men or bulbs are to be replaced at a particular interval of time. So that is nothing but the main objective of the replacement problem. For instance, in order to replace an item, whether to wait till it failures, till its failure, or replacing it at an early age with a higher cost, replacing it at an early age with higher cost. So item whether to wait till its failure. So one has to generally sometime, it is a human tendency to wait till the bulb fails or replacing it an early age with higher cost. So or else replace the bulbs and throw it away. And sometimes it is a usual practice to sell the machines in second hand. So that is the policy. So that is a different one. Equipment, whether to replace the inefficient equipment with similar types of equipment or with modern one. So these are the various factors that are to be considered while taking up the replacement policy. Equipment, whether to replace the inefficient equipment with a similar type of equipment or with modern one. So similar type of equipment or with a much modern one to increase the production. In case of high cost of equipment, the decision is whether to replace it immediately or later. So if it is a modern machine, if it is a higher cost, and the decision is whether to replace it immediately or after some time. So that all these things are to be decided. So that is these are the various factors that are to be considered. So immediately we have to wait for some time to replace until it failures. Replacing it at an early stage, replace with inefficient equipment. Replace the inefficient equipment with a similar type or with a modern one. So these are the things that are involved in this. Next, failure mechanisms of equipment. Failure mechanisms of equipment. The term failure has a wider meaning in business than what it has in our daily life. Failures can be discussed under two categories: gradual failures and sudden failures. The term failure has a wider meaning in business rather than what it has in our daily life. So failures can be discussed under two categories: gradual failures and sudden failures. So gradual failure means the mechanism under this category is progressive. This is as the life of an item increases, its efficiency deteriorates, causing increased expenditure for operating cost, increased expenditure for operating cost, decreased equipment's productivity. So decreased equipment's productivity is going to be reduced. Decrease in the value of the equipment, decrease in the value of the equipment. So automatically, if you continue to work on the particular, after some time, the value of the equipment is going to be reduced automatically. Next example, the bearings, pistons, piston rings, automobile tires, and mechanical systems like machines, machine tools, flexible manufacturing equipment, etc. fall under this category. The mechanism under this progressive, slowly, it is nothing but, it is not a sudden one, it is a continuous progressive one. So all these bearings, pistons, piston rings, all these things are to be replaced at a particular point of time. Depends on the working hours, you have to replace the bearings, you have to replace the pistons, all those things. So do not work continuously until it fails. You do not wait till it. So it is a usual practice to go for yearly maintenance or half yearly maintenance, and thereby it is better to replace the bearings, pistons, all those things. So if there is a sudden failure, it causes a lot of damage. Sudden failure. This type of failure is applicable to those items that do not deteriorate markedly with the service. That do not deteriorate with markedly with service. All these bearings, pistons, all those things deteriorate with the service. The bulbs, all those things, they do not deteriorate with service. But which ultimately fail after some period of using. For any particular type of equipment, the period from installation to failure is not equal, but will follow some frequency distribution, which may be progressive or retrogressive or random in nature. So you can take this failure of the bulbs, the sudden failure of the particular bulbs is one of the particular thing. So whereas the gradual failure means bearings, pistons, piston rings on automobile parts, all these things are depends on the severe service conditions. Service conditions. If you continue to work 24 hours per day, and it may fail within 5 years. And if you continue to work 8 per hours, it may fail in 3 years. So because of the service they delivered, so all these things depend. The life of the particular things, bearings depends, bearings, pistons, piston ring depends on the service. So this is sudden failure. We cannot predict the failure. So it is a sudden failure. Uh, they work up to particular point. After some time, they may fail suddenly, and the failure of such thing generally follows a particular pattern. It's a progressive uh, or this random in nature. So like that. Next, progressive failure. In this mechanism, probability of failure increases as the life of equipment increases. Probability of failure increases and as the life of equipment increases. So you simply the electrical light bulbs, automobile tubes, etc. Automobile tubes where the oil, hydraulic oil is pumped at a particular time, all those things. So electrical light bulbs, you can see that all the factories are housed with heavy electrical um, bulbs. And this is nothing but probability of failure increases as the life of equipment increases automatically. This is a progressive failure. Uh, 10 bulbs in the first week, 20 bulbs in the second week, 30 bulbs in the third week, and 50 bulbs or 70 bulbs, like that it is going to goes on. That is going to be a progressive failure. Retrogressive failures. Some equipment may prone to failure with a high probability in the beginning of their life. And as the time progresses, the probability of failure falls down. And that is the capacity of the equipment should survive in the beginning of the life, enhance its probable life. Industrial equipments with this type of distributional lifespan is exemplified by aircraft engines. So the fighter planes or the passenger planes, whatever it may be, if there is a failure, it may occur at instantly. If they continue to work, it's a long life they are going to give. So that is, this is going to be called as a retrogressive failure. So because of the severe service conditions, uh, it may fail initially or initially. After some time, if we continue to work for some time, start working, and it will give a long life. So that is the going to be called as retrogressive failures. Next, random failures. Under this failure, constant probability of failure is associated with the equipment that fails from random causes such as physical shocks not related to age. In such a case, virtually all equipment fail prior to their expected life. So electronic components like transistors, semiconductor elements, glass-made items, delicate or brittle items, perishable items like fruits or vegetables have been shown to fail at a rate independent of the age. independent of. So these are the random failures. We cannot predict the life for the particular thing. The electronic components, various electronic components like transistors, chips, all those things, semiconductor elements are glass items, brittle items. They may fail suddenly, or else they may give a long life. We cannot say, we cannot predict it. So there is a random failures, and you have to replace them as and when they require. So need for replacement. Replacement becomes necessary when the job performing units such as men, machines, equipment parts lose their efficiency and effectiveness because of gradual deterioration or sudden failure or breakdown. So the replacement is a must when while performing a particular job, either it is men or machines or equipment parts, whatever, they lose their efficiency or effectiveness because of gradual deterioration. Next, panel replacement, sorry, planned replacement of these items should reduce maintenance costs and other overhead expenses. Planned replacement is very important in the replacement policy. Planned replacement means, so you have to analyze or estimate the failure of the bulbs. You have to analyze, estimate the failure of the machines, and thereby you have to uh, estimate the failure life or the uh, or life of working, and thereby prior to that you have to place an order for the bulbs, you have to place an order for the machine, get it in time, replace it in time automatically through the old machine even though it is working. So you might have seen the auction of typewriters. So typewriter after working, after some time, they will completely put it for auctioning. Second-hand purchase people, they will go it. The purpose is to improve the efficiency in the office. It is a usual practice to sell out the typewriters after working. So in a similar manner, the lathe machines or whatever it may be, all the planned replacement of the items would reduce the maintenance cost and overhead expenses. When a machine loses its efficiency, gradually the maintenance becomes very expensive. Therefore, the problem is to determine the age at which it is most economical to replace the item. So, when the machine loses its efficiency automatically, and if certain vibrations are coming in the particular machine, automatically on the surface of the product, you will get chattering. Therefore, to prevent the vibrations, you need to replace certain parts. And in such a case, if you replace the parts, that is becoming a costly one. After that, it is a gradual maintenance. It is very expensive. Therefore, the problem is to determine the age which it is most economical to replace the item. So at which it is most economical to replace the item. That is you have to carry out. On the other hand, certain items such as bulbs, radio, television, computer parts fail suddenly without giving any indication, a failure, and they become completely useless. These items ought to be replaced immediately as and when they fail to function. These items are replaced immediately as and when they fail to function. Next, the two basic reasons for considering the replacement of an equipment or a machine are physical impairment, obsolescence. Physical impairment, obsolete. So obsolete means, so machine cannot work, hence it is to be treated as obsolete, and you have to keep it aside. So next, this physical impairment. What do you mean by physical impairment? Physical impairment refers only to the changes in physical condition of the machine itself. This would lead to a decline in the value of the service rendered, uh, increased operating cost, increased maintenance cost, or a combination of these things. So you have to physical condition of the machine itself refers to the physical condition. This would lead to the decline in the value. So if you change the physical position of the particular machine, automatically the machine loses its value, um, and therefore there is increased operating cost, increase in maintenance cost, or both the things. So, and if you sometimes if you alter the machine with some by adding certain electronic components and making it to work in a different phase, in a different manner, the maintenance cost is going to be increased or operating cost is going to be increased. Obsolescence is mainly due to the improvement of the tools of production or improvement in technology. So when there is um, good technology, improved technology in the market, a machine available with good improved technology, or definitely if you confirm yourself that with this new technology machine, uh, the production can be increased, then automatically you can go for the purchase of this machine by treating the earlier equipment as an obsolete. So like that, even though it is working, you have to treat it as an obsolete machine and you have to keep it aside. So for that, you have to replace the particular equipment with the new modern equipment with no improvement in technology. So that is the obsolete or obsolescence occurs at that particular point. So that is the importance of. So therefore, it would be uneconomical to continue production with the same machine under any of the above situations. Hence, the machines are to be periodically replaced. So it is uneconomical. There is physical impairment, obsolete, and this particular with these two conditions, it is very useless, uneconomical to continue the particular production of various products. And so the machines are to be replaced. The replacement situation arises due to the following reasons. Replacement: when the replacement takes place, weak performance of the existing equipment and needs expensive maintenance. Weak performance. So when the machine is producing a lot of vibrations and therefore it's causing a chattering on the components, so you need to replace certain parts. Therefore, all the parts, replacement of the parts causes expensive maintenance. So, and that is very important. In such a case, you have to analyze what is the cost of maintenance or the cost of the new parts and cost of the maintenance, all those things. And therefore, you have to analyze whether to go for, you have to decide whether to go for purchase of a new machine or old replacing the uh, old machine with a new machine or improved technology, or shall we go for the maintenance with the same machine. So if the cost of the new machine is very high, it is better to go for little maintenance, that is continue the present machine. Next, a failure of the existing equipment. Failure of the existing equipment because of industrial accident or some other reasons are anticipating the failure of the existing equipment soon. So this is another reason, failure of the existing equipment because of industrial accident. So if there is a sudden industrial accident and you cannot go for uh, purchase of a new machine, therefore it is better to go for with the existing machine. Next, third one, availability of mechanized and fully automated modern equipment with better design made the existing equipment outdated. In such a case, you must go for it. So if the present equipment is completely outdated, and if a new machine is available, even though it is a little bit costlier with the full automation and modern technology with a better design, all those things, automatically you can go for it, even though it is a little bit costlier, but it affects a lot in the production of the particular thing. That is, our intention is to improve the production, therefore it is better to go for this. So like that, these are the three factors that are to be considered. Next, the equipment whose efficiency gradually decreases according to the age requires paying out more money towards the running cost. The equipment whose efficiency gradually decreases according to the age requires paying off more money towards the running cost. So after it's continuous working, so it will take a longer, a large amount of money to run the particular machine and scrap, etc. Therefore, the only alternative ways to prevent such increased expense is the replacement of old equipment with new ones. So, if the running cost and maintenance cost are becoming higher, better to treat the existing equipment outdated and go for a replacement with a new one. So, that is the particular policy. Next, replacement for problems fail into the following categories depending upon the life pattern of the equipment involved. So, replacement equipment that wears out or becomes obsolete with the time. Replacement of equipment that wears out or becomes obsolete with the time. So, wears out means I told you wearing out completely, wearing out of the parts, rubbing parts of a particular machine. So, replacement of equipment with that wears out become obsolete with time. So, next, replacement equipment that fails completely. Replacement equipment completely fails. If equipment completely fails, automatically you have to replace it. There is no alternative. So, individual replacement policy. So, that is going to be called as a mortality theorem. Next, group replacement of items that fail completely. Group replacement generally exists in the example is nothing but the bulbs. Replacement of the bulbs comes under the group replacement policy. So lathe machine replacement or milling machine replacement or any other turning machine replacement comes under individual replacement policy. Next, other replacement problems, recruitment and promotion problems, recruitment of equipment, recruitment of men and their promotion problems, equipment's renewal problems. So these are the other replacement problems. Recruitment of men also, they have to be, if they are inefficient, they have to be thrown out. Or promotion, if they are very efficient, promotion has to be given. Next, miscellaneous problems for items that wears out. The problem is to balance the cost of new equipment against the cost of maintaining the efficiency on the old and are cost due to the loss of machinery efficiency. Though general solution is not possible, models have been constructed and solutions have been derived using simplified assumptions about the conditions of the problem. So, for items that wear out, the problem is to balance the cost of new equipment against the cost of maintaining. So, these are the other problems. Though general solution is not possible, models have been constructed and solutions have been derived using simplified assumptions about the conditions of the particular problem. You cannot find out a particular this thing. A separate but similar problem involves the replacement of items such as electrical bulbs, radio tubes, etc., or some electronic equipment which does not deteriorate with time but suddenly fails. So the problem in this case is of finding which items to replace and whether or not to replace them in a group, or if so, when. The objective is to minimize the sum of the cost of the item, cost of replacing the item, and cost associated with the failure of the item. So a separate but similar problem involves the replacement items such as electrical bulbs, radio tubes. So this is a group replacement. A sum of electronic equipment which does not deteriorate with the time but suddenly fails. So all these electrical bulbs, radio tubes, chips, electronic components, all these things fail suddenly. In this case, is to finding out which item is to replace, whether to. So we cannot say when the electronic components or radio tubes are replaced. We cannot. They may fail in advance. They may fail in advance, and the only thing is that you have to keep a inventory to replace the particular items. Bulbs are to be electrical bulbs. You have to keep 100 or 500 bulbs in advance, and thereby you have to replace them. So this is the other failure. The objective is to minimize the sum of the cost of the item, cost of replacing the item, and cost of associated with the failure of the item. So there is a book, S.D. Sharma. This is a very important book. Operational Research, Kedarnath Ramnath and co-publisher Merit has given various replacement models as follows. So replacement of items which deteriorate, whose maintenance costs increase with time. Replacement items which deteriorate and whose maintenance costs increase with the time. So this is a replacement of items that deteriorate with time will depend upon the value of the money and the corresponding associated costs. Now, costs to be considered. Various costs that are to be included in this model are all of those costs that depend upon the choice or age of the equipment. In some special cases, certain costs need to be included in the calculations. For example, in considering the optimum distance of replacement of a particular machine, the costs that do not change with the age of equipment need not be considered. The cost to be considered while calculating the optimum replacement period are capital recovery cost, average first cost if rate of interest is 0%. Running cost, average operating and maintenance cost. So capital recovery cost and running cost are very important. The above associated cost can be expressed as average cost per period, and the sum of the above two costs can be considered as total cost. Economic life of equipment, justification of replacement. So total cost to capacity, cost, all those things. Chart showing economic life. So generally this is total cost. These are the occupying the top line. The economic life of the machine is economic life, and whereas capital recovery cost it is decreasing with the life of the machine. Capital recovery cost, it is decreasing. Next, this is average main operating cost and maintenance cost. They are increasing. So this is the chart showing the economic life of a particular machine. A typical shape of each of the above costs with respect to life of a machine is shown in figure 1.4, from which it is clear that the capital recovery cost, average first cost, goes on decreasing with the life of the equipment, and the averaging operating remain goes on increasing. Averaging operating cost and maintenance cost. Every year, the operating cost and maintenance cost are going to be increased with the life of the equipment. From the beginning, the total cost goes on decreasing up to certain particular life, and then it starts increasing. The economic life of the equipment is the point of corresponding to the minimum total cost. So up to certain point it is decreasing, after that it is increasing. So that is what he is inferred from this. So the economic life of the equipment is the point of corresponding to the minimum total cost. So this is the particular point, the economic life, where both the things are increasing to decreasing. Next comes to, it can observe that the average cost per period goes on increasing longer the replacement is postponed. However, there comes on age at which the average cost per period tend to decrease. Thus, at this age, the replacement is justified. So, at this particular point of time, one has to replace it. Next comes to a machine loses efficiency with the time, and we have to determine the best time at which we have to go for a new one. In case of a vehicle, the maintenance cost is increasing as it is getting aged. These costs are decreasing day by day if we postpone the replacement. So this is the take one involved, the secrecy involved in the particular thing. If the interest rate is more than 0%, then we use interest formulas to determine the economic life. The replacement alternatives can be evaluated based on present worth criterion and annual equipment criterion. Next, replacement of items whose maintenance and repair cost increases. Repair cost increases with the time. So, ignoring the changes in the variable, ignoring the changes in the value of the money during the period. Replacement of items whose maintenance and repairing cost increases with the time. So when this maintenance cost and repair cost generally increases, ignoring the changes in the value of the money during that period. So we cannot say what is the value of the 1 rupee, but the maintenance cost or repair cost increases during that period. So this is the cost of maintenance of the machine is given as a function of increasing with the time, and its scrap value is concerned. So I'm going for the next class is beginning. I'm winding up this particular topic for today. We'll go for the next thing.